In this video, I want to have a look at solving simultaneous equations using a graphical method. So if we're asked to solve two equations simultaneously, that means that they're asking us to find the values that will make both of the equations true. So for example, if we were asked to solve y equals 4 minus x and y equals 3x simultaneously, we need to find values of x and y that make sense in both of those. So for example, if we looked at this equation just on its own, if we ignore this one for now, there's lots of answers that could make this true. For example, if we put x equal to 2, then y equal to 2 would make that sentence make sense because 2 is equal to 4 minus 2. Or we could have x is equal to 3, and that would make y is equal to 1. So we'd have 4 minus 3 is equal to 1. You could have it the other way around, you could have x is equal to 1, which would make y is equal to 3. But there's infinitely many you could have for an individual equation if there's two unknowns in it, two letters. But if we're asked to solve it simultaneously, we need to find the numbers that make sense for this equation as well as the first one. So if we have a look through our list for this one, if we put a 2 in here for x, that would mean y was equal to 3 times 2, which is 6. So this section here, those solutions don't make sense in this one, even though they did in the first one. If we have a look at this one here, if we've got y is equal to 3x, if we make x equal to 3, then we'd have y is equal to 3 times 3, which would give us 9, but we had y is equal to 1, so that one doesn't work either. What about this one? If we had x is equal to 1, we'd have 3 times 1 here, which would be 3, and y is equal to 3. So x equals 1, y equal to 3 is the solution to both of those equations. So if we're solving them simultaneously, this is our answer. But obviously that's not a very valid way of, or very practical way of solving these problems because you don't just want to have to guess and check. So what we can do is we can graph our solutions. So both of these equations can be represented by straight lines on our number plane. So if we graph both of them, then the point where they cross is called the point of intersection. And if we read off the coordinates of that point, that'll tell us these solutions. It tells us our x and our y coordinates or our x and y values. The only situation where this won't work is if the lines are parallel, because then there won't be a solution because they never will intersect. So let's have a look at what that means if we pull up some graphing software. So if we type in our first one, our first equation was y equals 4 minus x. So that's that straight line there. And our second equation was y equal to 3x, which is that equation there. So you can see that the point where they cross here has an x coordinate of 1 and a y coordinate of 3. So we can put our point on there if we want to. And it reads off 1, 3 as the point of intersection. So that means our solution is x equals 1, y equals 3, which is what we had. Now, obviously, if you've got your computer in front of you, using graphing software is a really nice and easy way to do it. But we won't always, especially in an exam, you're going to have to do this by hand. So let's have a look at an example. So for our example, we're asked to graph the equations 3x plus y equals 4 and the equation x plus y equals minus 2 on the same number plane and then solve the equations simultaneously. So to do this, let's start with one of them. So we're going to have 3x plus y equal to 4. Now, one of the easiest ways to figure out how to graph this is to draw up a table of values. So if we draw up a table of values, we're going to have our x values and our y values. You should be trying to make this as neat as possible as you can in your book. We need to pick a couple of x values we're going to substitute in. So let's pick some nice ones. Let's pick 0, 1, and 2. It doesn't matter which numbers you pick, but 0, 1, and 2 are really nice numbers to substitute into things. And you always want at least 3 numbers, so you know you're getting your straight line in the right spot. All right, so let's sub in 0. So if we substitute in x equals 0 into this equation, we would have 3 times 0 plus y is equal to 4. 3 times 0 is just 0, so that means y is equal to 4. So we're going to have 4 here. Now if we do x is equal to 1, we'd have 3 times 1 plus y is equal to 4, which means that 3 plus y is equal to 4. And if we subtract 3 from both sides, we'd end up with y is equal to 1. So we'll put that here. And our last one, if x is equal to 2, then we would have 3 times 2 plus y is equal to 4. So 6 plus y is equal to 4. And if we subtract 6, we'd have y is equal to minus 2. Now we need to plot these points on a number plane. So our first point is this one here. So the coordinates are 0, 4. So x coordinate of 0, y coordinate of 4 would be up here. Now we've got the coordinates 1, 1, so we go across 1, up 1, just here. And then we've got the coordinates 2, minus 2. So 2 minus 2 would be down here. Now, they should line up in a straight line for all the questions that we're going to be doing. If they don't, that means one of your calculations is wrong. And that's why we always do 3, just to check. Because we're going to be reading off this graph, it's really important that your number plane is accurate, that it's all measured out into scale, and that you're using a ruler for these. Now, I can't on here, so I'm just going to do the best I can. All right, so that is our first line, and we're going to label it so we know which one it is. 3x plus y is equal to 4. So now we're going to do the same sort of process, but with our other lines. This time we have x plus y is equal to minus 2. So we'll draw up a table of values again. Let's pick 0, 1, and 2 as our values for x. So if we sub in x equals 0, we'd have 0 plus y is equal to 2, which just means that y is equal to 2. If we have x is equal to 1, we'll have 1 plus y is equal to, oh hang on, sorry, that should have been a minus 2. Those are minus 2's there. I read my equation wrong. So we'd have 1 plus y is equal to minus 2. If we subtract 1 from both sides, we'd have minus 3. So we've got minus 3 here. And our last one, if x is 2, we would have 2 plus y is equal to minus 2. If we subtract 2 from both sides, we'd have y is equal to minus 4. So plotting our points, we'd have 0 minus 2, so down here. We'd have 1 minus 3. And we'll have 2 minus 4, so down here. So again, you want to draw a straight line through those as best you can using a ruler. We've drawn on our second line. So the last thing we want to do is solve the equations simultaneously. So we want to find the point of intersection, which is this point here. So that point has coordinates 3, so an x coordinate of 3 and a y coordinate of minus 5. So that means that our solution is x equals 3, y equals minus 5. After you've graphed it, it's always a good idea to come back to your equations at the start and make sure that those numbers do make sense in both equations. So for our first one, we'd have 3 times our x coordinate, which was 3. And then we'd have plus y, so minus 5 in this case. And we want that to come out to equal 4. So 3 times 3 is 9, and minus 5 is 4. So that equation is true for those two numbers. If we test in the second one, we've got x plus y, so we'd have 3 minus 5. 3 minus 5 would give us minus 2, which is what we were after. So that's our way of double checking that we have solved it correctly. So that's having a look at solving simultaneous equations graphically.